Hi everybody, today we're going to talk about graphs of polynomial functions. What I want you to think about as we start to graph them is that polynomial functions that are degree 2 or more are going to have graphs that don't have sharp corners. They're going to be kind of smooth curves, which we also call continuous. You could draw this without picking up your pencil. You could just keep kind of moving along, going up and down to draw these functions. If f of r is equal to 0 for any real number r, then r is a real 0 of the function f of x. And this means a lot of things. It means that x minus r is a factor of f of x. It means r is an x-intercept of f of x, and r is a solution to f of x equals 0. So we kind of get multiple things out of this one little piece of information. Let's find the zeros of f of x is 3 times x minus 2 times x plus 4 squared. We'll take each of the factors, like x minus 2, set it equal to 0. We'll take the x plus 4 squared and set it equal to 0. X minus 2 being 0 says that x is equal to 2. If x plus 4 squared is equal to 0, then x plus 4 is 0. So we can drop that exponent. You can take the square root if you want, but really square root of 0 is 0, so I'm just going to drop exponents all along, and I get x is equal to negative 4. So I have two zeros here. I have 2 and I have negative 4. The degree comes from adding up all of the exponents to each of the factors. So what you want to think about is if we were to expand this polynomial, the x plus 4 squared would give me an x squared. I would have times the x minus 2, and that x squared times x would leave me with x cubed. So we are not going to expand this all out, but we are going to think about adding up these exponents. Remember, degree is just the highest power of any particular term in the polynomial. Let's do one more like that. I have f of x is 1/3 of x times x plus 5 times x minus 8 cubed. I see 3 x's. If you want to keep the 1/3 with the x, that's okay. We'll set it equal to 0. X plus 5 is 0. And x minus 8, and I'll write it as cubed, is 0. With the 1/3 of x being 0, you could think multiply both sides by 3, and you're still going to get zeros. X plus 5 says x is negative 5. Again, I'm going to drop the exponent of 3. I have x minus 8 is 0, so x is equal to 8. So 3 zeros this time. Go back to the degree. With the degree, I'm looking at the overall exponents for each of the terms. So I have an x, I have x plus 5, I have the x minus 8 cubed, which says 3 plus 1 plus 1. So I'm taking these exponents, I'm adding them up, I get 5. So my degree is 5. So these powers we're talking about for each of the little factors, we really have a name for that called multiplicity. So if m is the highest power for which x minus r is a factor of f of x, then m is called the multiplicity of r. So each of the factors have their own multiplicity. Let's look at this example, y equals 2x cubed times x minus 1 squared times x plus 2 to the 4th. And we are going to find the zeros and the multiplicities for each of the factors. So I have the 2x cubed, which says we have a 0 at x equals 0, and the multiplicity, which I call m, is 3, so it's just the power for the 0. My next one, I have x minus 1 squared. Well, that says x is equal to 1, and my multiplicity is 2. Then x plus 2 to the 4th has a 0 at negative 2 and a multiplicity of 4. If I add these up, 3 plus 2 plus 4, that is equal to 9, which is our degree of the polynomial. Multiplicities are super important because they tell us a lot about the graph. And we're going to break it into two parts, even and odd. So when m is even, f of x is going to touch the graph at x equals r. So I put up the graph of x squared because I think we're familiar with it. And you can see I'm just touching the graph at the origin. I'm not going through it. I'm staying positive. So I'm just kind of coming down and going back up. So you can think about it as touching a turn if that really helps you, but I want you to see this idea of touching at the intercept. Let's compare that to an odd multiplicity, and an odd multiplicity is going to cross the graph when x is equal to r. So you can see here I was above the graph, and now I am below the graph, and I went through the graph at the 0. So I think evens touch, odds cross. So look at this function, f of x is negative 1/4 times x minus 1 times x plus 2 squared times x minus 4 cubed. We are going to find the multiplicity of each factor of this function and talk about the degree of the overall function. I like to make a chart to kind of organize what I'm doing. And the things that are going to go in this chart is we want to know the zero or the root, so whichever one you want to call it. We want to find the multiplicity, and then we want to know, is it going to touch or cross the x-axis when it gets to that 0? So I have 3 zeros. From x minus 1, I have a 1. From x plus 2 squared, I have negative 2. And from x minus 4, I have positive 4. The multiplicities are the exponents, which happen to be 1, 2, 3. When you look at the multiplicities, you think evens touch, odds cross. 1 is odd, it's going to cross. 2 is even, it's going to touch. 3 is odd, it's going to cross. Notice the touch and cross comes from the multiplicity, not from the 0. Altogether, to get the degree, I'm going to add up my multiplicities, 1 plus 2 plus 3, which is 6. Let's take a look at graphing that. So I made a little xy plane, and I'm going to start with putting on the zeros. So I have a 0 at 1. I have a 0 at negative 2, and I have a 0 at positive 4. Now, we said the overall degree is 6, and we have a leading coefficient that's negative. So you're putting together what we know about end behavior along with multiplicities now. So the negative says when I go to the far right, I am going to go down. Then I look at 4, which says it crosses. So when it crosses, it goes up and over to the next intercept, which is 1. At 1, it also says it crosses, so it's going to go over until it gets to the negative 2. And then at negative 2, it says it touches, which says it goes down. Now, this is really good because we can go back to what we know. Degree of 6 is even, evens match, so I can see this end behavior here is the same. Sometimes you might be asked to also find the y-intercept, which means you would plug in f of 0. And then get the value there, and then you would put it on as well. So I'm not going to do that on this one, but just to say it could be another point to use just to make your graph a little more accurate. Overall, we're doing a sketch. We're not doing a table of values, but we get a good idea of what the function looks like. Let's try a second one of those. I have f of x is negative 3 over 100 times x minus 1 squared, x minus 5 squared, and x plus 2 cubed. My first thing I want to do is make my little chart. So I'm going to have zeros. I'll have multiplicities, and then I'll say if it touches or crosses. So my first 0 is at 1, my second 0 is at 5, and my last one is at negative 2. The multiplicities this time are 2, 2, 3, so 2, 2, 3. 2 and 2 even, so that's going to be touches. 3 is odd, so it will cross. Overall, the degree comes from 2 plus 2 plus 3, which is 7. So I have an odd one this time. Odd makes me think I'm going to have opposite end behavior when I get to the graph. So we'll start with the little xy axis. I brought our chart back over so we know our zeros are at positive 1, positive 5, and negative 2. Like last time, I look at the leading coefficient, which is negative, which says the function goes down. Then at 5, because it's even, it's going to touch. So it's just going to kind of bounce around, go to the next intercept, which is 1. 1 also has an even exponent, so it will do the same kind of thing, a bounce around, go to the negative 2. Negative 2 has an odd multiplicity, which says it goes up. This matches our degree 7 because we talked about it would have opposite end behavior, which the graph does.